Let me introduce today's speaker, Syberry Software Development Engineer in Test Ekaterina Volkova. She will share how she tests her tests on Syberry's projects. So, Katya, the floor is yours, please.
Thank you, Nastya. Hi, everyone. Do you hear me well?
Yeah, I think so.
Okay, super. And you're able to see the screen sharing, right?
Yep.
Cool. Hi, everyone again. My name's Ekaterina Volkova, and today I want to talk to you about automated testing. And first, let me introduce myself and tell a little bit about my experience and why actually I might be worth listening to. 6 years ago, I started as software test engineer, and for last 4 years, I've been working in Syberry as software developer in test. During all this time, I worked on different web applications and backend services. I tried different tools and testing types, most of which were focused on functional testing. And today, I would like to share some of my experience with you. And to give you an overview of today's webinar, here's the list of questions I'll try to address during today's session. So firstly, we'll talk about why we actually need to test our test. Then we'll check different aspects of good, non-buggy, reliable tests, such as sufficiency, functionality, and non-flackiness in details. Then we'll summarize all of the above, and we'll have some questions and answers session, during which you would be able to ask your questions, and I will be really happy to try to answer them. Okay, so let's start with the simple truth. Not testing your software is cringy. Everyone does it. Because errors in software are costly, and engineers find better and faster ways to test their code. We test code manually, we test code automatically, we can do it on different levels of code isolation, and so on and so forth. If to put it in short terms, we write test code, and our test code tests the main code. But still, our test code is code, which means it might still have bugs. And now there is a question. How do you ensure that the code that tests your main code is not buggy itself? How can we prove that our tests actually test what we intend them to? And these are basically the questions which I would like to try to answer today together with you. If we catch a bug with the test, that's really cool, because now we know that there is a defect which needs to be fixed. But what if we don't catch the bug? In this case, do we actually know that there are no bugs in the system and functionality? Probably yes, if we have really extensive tests through application on different levels of code isolation, then probably we can be quite certain that we don't have at least any major bugs. But what if our tests are buggy themselves? Because the fact that the tests are green doesn't mean that our system or specific functionality, part of our system, is bug-free or functions as expected. Yes, and we would like actually to rely on our test, correct? And in order to rely on the test should adhere to following criteria. First, our tests should be functional and correct, which means that our tests should test the functionality properly, similar to validation in testing terms. Also, our test should be sufficient, and here I'm not referring to to a test in isolation, but more in general about the test suite. So we need to ensure that we didn't miss any checks. And the third one is non-flakiness. Now I propose you to dive into each of these characteristics of good reliable tests and check how we actually can ensure the quality of our tests within each aspect of this. And we'll start with test efficiency. If we test some feature, no matter manually or automatically, and there is some requirement which was not implemented, what do we do in this case? Correct, we would create a defect for that. And same can actually work with tests. If there are not enough tests, we can say that there is a bug. It's just a test bug. And for sure, we want to get rid of bugs of all types. And what tools do we have here to ensure that the tests are actually sufficient? And the first one would be code coverage. So with the help of code coverage, we can measure to which extent the main code is exercised by automated tests. In industry, there is a plenty of tools which could do these jobs for you. For example, Jacoco, Cobertura, SonarQube, and much more. You can see some of them on the screen, but for sure there are much more rather than this. I personally work and like Jacoco, but it's up to you to decide which one would be good for you. Jacoco is pretty much simple, easy to set up, configure, and analyze the results. And now I would like to check this tool under a practical example to show you the capabilities of code coverage as a tool for ensuring the quality of your tests. So here, let's see, we have a class which called contract service implementation. It has a bunch of methods, but we would check only one, it's add contract. We're actually not really interested in the business logic which is covered in this method, but we can see that there are different conditions in this method. So let's say that in order to store the contract, we would rely on some attribute, and depending on the value of this attribute, we would apply different logic. And let's suppose we have a test for it, a unit test. It's only one. It tests this method, and it could be really a good test. But if we apply code coverage task to this class, we would be able to see what lines actually were covered by our test and which not. So if we check in this example, we can see some green lines, red lines, and yellow lines. So green lines are actually the lines of code which were called by the test. And red lines, red highlighting means that this condition was never called. So this is actually a direct hint for us to go and check our test. It's basically saying to us, hey, you see that here you have a test, but this test is not complete. It doesn't test this condition, it doesn't test this branch. So on this basic example, we can see that code coverage actually a good and powerful tool which could show us where our tests were not enough. But there is one problem. Code coverage tools can measure effectively only on very low level tests like unit tests, which is highly helpful to developers and not always to us as quality assurance engineers um, because we are dealing mostly with higher test levels like integration tests, acceptance tests, end-to-end tests. And for sure, we would like to ensure that our tests are sufficient not only on unit test level, but on other levels such integration end-to-end test. And here I can propose you to use a traceability matrix. So traceability matrix is a concept which is actually widely known in the terms of manual testing, and this is used to map test cases to requirements. And one of the main goals of this tool is to ensure that your product meets the customer requirements completely. And here, I suppose, there is no actually difference in manual test cases or automated tests, no matter on which level. For sure, we can map our tests with the requirements or with the acceptance criteria for the feature, functionality, or the whole product. And this tool would help us to ensure our test sufficiency. That's all I wanted to share about test sufficiency. And now let's go to other fundamental aspect of good reliable tests, which is functionality and correctness. When testing, we often say it's not functional. And we say this to point that the functionality is not working as expected, like at all. And vice versa, it's fully functional, we say this, when everything is tested and no at least major bugs showed up. And we can actually transfer this concept to test as well. And in this case, when we can say that our tests are functional, it's actually easy with failed tests. Because if the test failed, there can be two reasons for this. So our test can fail and there is actually a bug in the functionality which is related to this check. And this says to us that our test is fully functional because our test does what it intends to do. It just found a bug. That's good. And also we can have another condition when our test failed, but there is no bug. That means that there is some problem in the test itself, that our test has bug. But still, it's an indication for us the test is not functional. So we can clearly identify whether the test is functional or not. And it's not actually that easy with our green passing test. Because it's not really easy with our green functional tests because we cannot be sure that they are functional or not. Do they actually perform valid checks or not? And even are they testing anything or not? And this is actually something that could be clarified by another tool. And this tool, I'll introduce it, could actually give an answer to these questions. And this tool is called mutation testing. So in general, mutation testing is the act of applying some small changes to the original code and then checking that the test failed. And before proceeding to the mutation testing in details, I would like to ask you a question. Have you ever applied mutation testing on your project, or at least have you heard of them? Here you will have some time to answer it.
Yeah,
And then
we'll give
wait.
you a minute to answer the question.
Cool. I can see that some people actually use mutation testing on real project, and that's really cool. Maybe you guys could share in the chat, like what was your experience with this type of testing, and whether was it successful, whether this helped you to improve the quality of your test. This is actually really interesting, I suppose, for everyone here. Okay, we can see that a half of you guys here actually at least heard about mutation testing, and that's great. And on almost a part of all the participants of the poll never heard about this type of testing. So at least you guys will hear now useful information about it, as you never heard about it. Okay, let's continue. So, mutation testing is a technique used to evaluate the quality of software tests. It consists, like here we can see the flow of this concept of mutation testing. We have an original program, our application, our code, and the framework, mutation testing framework, actually does the job for you. And the framework intentionally inserts some pieces of modifies some pieces of code intentionally, and then we can check if our tests, like original tests which are passing on the original program, we can check if they fail, because this is what we expect them to do. If our tests pass on the original program which is supposed to be tested, then if we intentionally put some bugs into code, we expect our test to fail, right? And this is actually the concept of mutation testing. If the tests are executed against the mutant program and our test passed, that's not actually a good thing for us, because some mutants survived, and this indicates that potentially we could have a bug in the system and our test would not find them. And vice versa, if our test failed, in this case we can say that mutants were killed, and we can rely on such tests, and know that they would actually find some bugs and they are actually functional. And here I described the flow. Next, you can see different mutation testing frameworks. In the industry, there is a bunch of mutation testing frameworks. They are written for different languages. For example, PyTest is for Java and all Java-based languages. Striker can be used for JavaScript, TypeScript, Mute for Python, Infection for PHP, and there are much more. So depending on the language you use, on the project needs, you can for sure find something which would suit and help you on your project to ensure and improve the quality of your test. And now I would also like to jump to check the capabilities of mutation testing on some example. And for example, there is the same class which we saw when checking code coverage example. And here we can see that we have contract service implementation class. Here there are their methods. Here we can see that we have tests written for this class, and we can see that these tests actually pass. They are green, they are passing, so it's intended that the service actually is tested, but now we want to be sure that it's tested properly, correctly, and functionally. I applied the mutation testing task to this class, and the report was generated. By the way, I used PyTest, and here you can see the part of report. So first we have an original code of our class, which is highlighted green and red. So the lines which are highlighted in green, this means that the mutant was actually generated for this line and the mutant was actually killed. So the green here is good, red not so good. So red means that the mutant was generated for this piece of code, for this functionality, for this line, but the mutation was applied to it, but our test didn't fail, so they passed. So tests were not able to detect this issue. Okay, we can see it, but without a proper description, we don't understand what actually was wrong with our test. And here, then later on in the report, we can see the mutation section, which actually describes what kind of mutation was applied to this or that line. So here for add contract methods, we're interested in line 38 and line 40. And here we can see what was wrong with these lines. On line 38, the mutation framework removed the call to set duration in year method. And in line 40, it removed the call to set employee method call. And now we can analyze. We can analyze and decide what if the test actually needs some refactoring. So if we go back to the original method, we can imagine that there would be some developer, for example, some new developer who joins our team, and by mistake, the developer thinks that these lines are not needed at all. So by setting an employee to contract, might be a really important thing because by requirements, the contract cannot live without employee. It should be also always attached to employee. And here, if we remove this line, for sure we'll have a bug in production, right? And this clearly points us to our current tests are not able to find this bug. So this is a direct hint for us to go and check our tests. Probably we need to fix the test data that is generated for this test. But still, if we have any kind of these issues, we need to go and check our test and decide whether this is actually helpful for us or not. And especially here, we need to refactor our test so that this would actually catch that bug if this would actually ever happened. If to check the report, also after mutation section, there is active mutators section where all the categories of mutators which were applied to this class are shown. If you're interested, you can go to the official website of the framework. You want to try and check what all of they mean and which changes exactly to the code are made within these categories. and also a list of all the tests which participated in this report generation, the analysis on which. Okay, so now we can clearly see that mutation testing can give us some benefits. It can help us to ensure the quality, right? But of course, there are drawbacks as well. And the first one is that, again, the mutation testing can be executed only to low-level tests like unit tests, component, probably sometimes integration tests, and not higher ones. And running mutation tests actually is a costly operation. Especially if we want to run these tests against the whole existing code base. And actually, a second drawback is a little bit, can be actually mitigated with the help of another tool which could help us to ensure the quality of our test. And this is test-driven development. So test-driven development is a software development practice when we first create a test that fails, then we write code so that the test would pass, and then we refactor. We can repeat this cycle until we have passing tests and good code, but in general, the flow is this. Why test-driven development actually ensures our tests being functional? Because initially they failed. And then we created a code that made this test pass, so we are sure that our test kind of functional. Previously I said that the second drawback of mutation testing, which is being really expensive, time-consuming operation, can be mitigated with test-driven development. And now I want to discuss why these both can be actually combined. Because the mutation testing is really expensive operation when we apply to the all existing code base. But if in our project, in our team, we stick to test-driven development approach, we created functionality, we have tests for it, and in our usual TDD flow, we just can add one more step, which is, so first, we will write a file test that fails, then we'll make the code work, and then we'll apply mutation testing on the affected code. So the code base here is not huge. We'll mitigate the drawback of time consuming, and we'll be sure that our tests are not only functional, but also effective and bug-free. Okay. Again, these both test-driven development, mutation testing are really nice tools, but again, they are working with unit tests mostly. And as software quality engineers, we more often work with higher tests. And we would like to ensure that our end-to-end tests, acceptance tests are functional and correct as well. And how we can do this? Unfortunately, there is no magic wand that would resolve the concern of end-to-end tests being correct. But there are several tips and approaches that you could consider while creating or refactoring your test suites to avoid, or probably at least reduce, the risk of tests being buggy. And here you have them. code review. So I don't actually think that code review needs a description or proof that it's a powerful tool, but it's just a must both for pull request with main code and test code. Just do code review really carefully. It really helps, and it really helps to make your test more qualitative. Then make sure that you actually implemented assert. You could probably say that, come on, that's not possible. No one could forget to implement assert. But, like, trust me, that's possible. And that's possible because we are all humans. We can make mistakes, and that's okay. It happens. But here I would also like to remind you about the role of static code analyzers tools, because if to refer to the previous concern that we could just forget to implement an assert, static code analyzers tools would definitely catch this up. And this is not only a case which could be caught with static code analyzers, because again, our test code is still code, and we want to have this code structured, non-buggy, a quality code. So just consider incorporating static code analysis to your test sources. Probably you would modify, you would apply different rules to your test sources rather than to the main sources. But still, this would help you to catch bugs in your test code. And also, what I wanted to mention here is critical thinking. By this, I mean that you don't need to consider the actual implementation as is, especially when we are working on automation of feature which is already in production, or which probably was already tested manually or with other testing types. Just don't assume that how it works now is the actual expected behavior for the system. Always put it under doubt, and always double check with requirement, with specification, and in cases where you need, with product owners or business analyst. Okay, that's all for tests, functionality, and test correctness. And now let's go to the last but not the least aspect of the good reliable test, which is non-flakiness. What is flaky test? So flaky test is a term which is used to describe a test which is not constantly reliable. In other words, a flaky test can produce different results, pass or fail, when run multiple times under the same conditions, and even if there were no code changes. This inconsistency can make really difficult to determine whether a test failure is indicative of a real problem that we have in production in our, or not in production, just in our software, or just a result of test being unreliable. Pretty much the same as the usual bug reporting in usual manual testing, because before filing a bug, we reproduce it several times, correct? Because it's crucial to know if it's always reproducible or not. So the same with tests. Flaky tests are bugs in tests which are not always reproducible. And how we can actually address flakiness? We can do it in two ways. The first one, we can find it before the actual test creation, while we design the test suite of framework. And another one is when we already when it already happened, when we have a case when our tests fail, some of them, for example. And let's start with preventive options. So what recommendations, what tips do we have here? The first one is to isolate your test. We should ensure that each test case is fully independent and doesn't actually rely on the state or results of other tests. This reduces the chances of test interference. Another one is to use explicit weights. When dealing with asynchronous operations or waiting for elements to be displayed in UI tests, use explicit weights to ensure that you wait the expected condition to be met before actual proceeding. And dealing with test data. So when developing your test framework, your test suite, take care of your test data. Develop your own set of test data and make sure that no tests actually update or delete none of this basic data. Also, make sure that no one could interfere with your test data, with your test, with your environment while you run this test. And for this you can use different options as well. You may have a dedicated test server against which you run your test suites, or for example, you can use some test servers using virtualization or cloud computing. This will ensure that no one interfering with your testing environment externally. Okay, cool. So we followed all of the best practices while designing, creating our tests. We considered all corner cases, all possible issues that we could actually face, and incorporated all of our background experience, previous experience, and still we have some flaky tests. It's completely okay, again, same as when we have bugs in software under test. It's okay to have bugs. The hardest part from it actually is to reproduce it, because in 99%, because most likely you found your test being flaky when run on CI server, and when you rerun this test locally, in 99% of cases, your test will pass when rerun from local machine. And by the way, if you guys had some interested cases related to test flakiness and you want to share them with us, you could do it in the chat. Also in the background, we'll check and probably will find something useful for all of us as well from your cases. So if you have some, please feel free to share them. Okay, going back to recommendations. So the first one is to inspect test logic. We need to carefully review the test logic and make sure that our test is actually deterministic. Avoid using random data or relying on some order-sensitive operations. Also, pay attention to data created on the fly. What does this mean? Sometimes in our tests, we have some data which is generated on the fly. The simplest example is current time. We sometimes need it in our test. And I can even share one case from my experience when I had a bug in my test related to this point. So The bug actually was related to incorrect usage of Java simple date format pattern. You know, there is for year indication, there is pattern with Y capitalized and not capitalized. And this is actually different things, because a capitalized one means not a usual year representation, but a week of the year. And I confused them, and this resulted that my tests were failing in the specific days of year. So be careful with it, and always check your tests for this on-the-fly data. The next tip is to examine concurrency and race conditions, because we all know that if our code involves multi-threading, concurrent processes, parallelization, look for these race conditions and contention points, because in major cases, this is the problem which causes test being flaky and buggy. Also, I would say that we can use actually the test framework capabilities and be creative a little bit here. Because test framework features sometimes can help us to reproduce the issue locally if we actually use them. And here I also can share one case from my own experience. I had a test which was failing on CI server sometimes. So some builds were passing fine, some not. And I went to my local machine and I ran the test, it passed. I reproduced it like 3, 5, 7 times, and it was always passing. And at some point, I decided to put a repeated annotation on the test with 100 value and made the framework run this task like 100 times for me. After I saw the results, I saw that two cases out of this 100 were actually failing, and this gave me a complete understanding why the tests were failing, because they were failing again at a specific moment of time. So here, JUnit helped me to debug the failing test. Also, what we should check. We should check for resources leaks, such as unclosed files or network connections. These things can lead to test failures, especially over time. But again, here I would like to emphasize the importance of static code analysis tools in your test sources, because, for example, resources leaks such as unclosed files would be easily catched by the analyzers and not in the real moment when you have a test, a flaky test. And the last one here is environmental factors. So be aware that environmental factors such as system load, network condition, different hardware variations can sometimes lead to and contribute to your test flakiness. So when debugging and checking your test, pay attention to it and compare what differences it has from your local machine. Okay, these are basically all the tools, approaches, tips and tricks that I wanted to mention for today's webinar. And I truly hope that you guys were able to extract some useful information from it, and probably even will incorporate some of this into your daily work. Thank you really much for your attention. And now I'm ready to answer all of your questions.
Yeah, thank you, Katya. We actually already have one question in the chat, but if anyone has something else to ask Katya about automated testing or manual quality assurance, feel free to just shoot us with a question. There is one question from Nazi, if I'm pronouncing the name correctly. They're asking, do we have to write the mutation tests ourselves, or are there tools already pre-written to just mess with the code and see if it fails?
Yes, I understood the question. Thank you for it. So if you want to incorporate mutation testing into your project, you don't need to intentionally make code changes by yourself. There are plenty of mutation testing frameworks which would do the job for you. So you don't need to, you just choose your framework which suits your application most. You incorporate it into your project, and you just run the mutation testing task. It would be as easy as this, and then you just analyze the report. So you don't need to make code changes by yourself. But actually, you could, if you want to do this. You for sure can do this. But I think that in this case, you will need to put a lot of effort into your testing, especially when there are dedicated tools which could do this all for you.
Cool. Nazi, let us know if we answered your question. We have another question from Mikhail. He asks if mutation tests can be integrated in CI/CD pipeline.
Yes, sure. They can be incorporated into your CI/CD pipeline. It just depends on the needs that you actually pursue with it. If, for example, you just want to run mutation tests, the test for whole existing code base of all of your tests each time, this doesn't actually have a lot of sense, because the operation is time consuming by itself. And if we just put a usual mutation testing task on the whole code base, it would just do the same job over and over again and just waste the time. The really good thing here, which could be actually applied, is to apply mutation testing to some parts, for example, for new tests, or as I was mentioning, if you use a combination of test-driven development with mutation testing, you could incorporate this into, for example, your pull request. And and for example, let's imagine we have a separate pipeline which is run when you when you raise a pull request. And then it would be helpful if this mutation test would be run only in that stage and only for that new test, for new functionalities that you created. So you would be super sure that not only that your tests are super functional and qualitative. I hope I answered your question.
Yeah, Mikhail, let us know if that helped. We also have a question from Anna. She asks, is there any tool that can track flakiness automatically and provide with a report?
I think if you're referring to end-to-end tests, probably to UI tests, I actually didn't use any, but I'm pretty much sure that there are some, because it's not really really difficult to find, to analyze, to store the results for the consequent runs, and to have the information stored, for example, in some database or something like that about a specific test history, if it passed or failed. And I suppose based on this data, there should be some tools which would actually analyze and give you statistics of which tests are flaky. And also, as far as I remember, when I use Cypress, for example, I don't know what tools do you have, what do you use, but for example, in Cypress, you could with the paid option, not the free one, where you connect to the Cypress dashboard. There is also statistics about your test run, about your test's flakiness and reliability. So I'm sure there are much more tools.
Cool, thanks. We have another question from Nikita. Thank you for being such active participants in this webinar. It's really, really enjoyable for us. So Nikita's asking, could you please share your opinion about using rerun feature available in most of the frameworks as a way to deal with flaky tests?
I don't have like certain opinion on that. I think it really depends on your project. So there is such a feature for rerunning your test, right? You can and like I would say that it's really cool if you would just try it and like make a conclusion by yourself if this is helpful to you, if this gives the result that you want to achieve. But in general, yes, it's kind of helpful feature because usually when we encounter a flaky test, if we don't have this rerun feature, if we don't have any analytics on whether the test is flaky or something like that, we should go and check the test manually, or we should go and rerun this task, right? And here, this rerun functionality is kind of the automation on our work. So for sure, this could save the time for you, but again, it's up to you to use it or to not.
Great. We hope we asked Nikita's question. If not, let us know. We have a question from Marta. She asks if you could elaborate why exactly mutation testing is costly.
Yes, actually, because let's imagine we have a code base with 1,000 unit tests. It's pretty much okay number for a number of unit tests, and they run for a specific time. Unit tests are fast. That's right. Yes, they are fast. But here we run this test like multiple in a number of times multiplied by 10, by 15, by 20, because there are lots of mutators that can be incorporated into your code. So the framework first needs to analyze all classes. The framework needs to inject these code changes to compile these classes and then to run a set of tests. And this happens like 10, 15, 20 times. That's why it's expensive, because we have a huge number of these tests.
Cool, thanks. Nikita asked us another question, and I think we have time to answer a couple more. He asks, what's the % of time budget you are spending on the mutation testing relatively to the whole test runtime measurement?
Nice question. I would start the answer with that actually I personally never applied mutation testing on the project I was working for. Only like in purposes to gain knowledge and to try. And probably for some small projects which were done but not very experienced developers, to check if actually their test check something. But I never applied this on the production project. But if to try to answer to your question, there should not be actually a lot of effort into that, because you don't need to change your test. You don't need to change your code. You just need to incorporate the testing framework. For example, I work with Java. I go to the project. I just add a library responsible for mutation testing. I just import it, and I am able to run the task and incorporate it to the build. The only thing is that it's costly from time usage perspective. Probably, for example, if you can, I don't know, probably you want to incorporate this into your project. You want to check how efficient, how effective your tests are. You can, I don't know, just run this once. Probably you can even incorporate it into your pipeline and run this task on CI to put it for example, for weekends or for a night, and check. And in this case, I suppose it will not cost you like pretty much nothing. Just the resources of like CI server or of your hardware on which this process take place.
Cool, thank you. We have one more question from Mikhail, who asked about mutation tests and CI/CD pipeline. So the follow-up question is, if we add these tests only on the PR step, does it become the responsibility of the software developers?
So this is actually depends just on your processes inside your project, because if you raise APR with you, okay. Let's start with this. There can be two cases: when QA raises APR and when a developer raises APR. When it's a developer, most likely you made a code and you made a unit test for it, right? And you check your test correctness against that part of code. Yes, if these tests are failing, mutation tests, so if they are not failing here is not a correct word, but if you're not happy with the results the mutation testing analysis gives to you, yes, then it's your responsibility probably to fix them. Or you can probably, I don't know, create a task for a future refactoring of tests for other developers or for QA engineers. It truly depends on the processes that you have in your project. And also, I would like to mention that a mutation testing task as is, it doesn't actually fail the build, and it doesn't actually show you none of the results, just like your tests are good or your tests are not. In order to check it, you need to analyze the report. If you want to incorporate some strict rules for it, for example, as similar to code coverage rules. For example, fail the build if we have less than 70% of line coverage for the whole project, right? And in this case, the build would fail. Same we can do for mutation testing. We can set up a rule which would say that if the test strength, this is a concept from mutation testing. You could, if you're really interested, you could find the information in the internet. But there is a test strength ratio that is calculated by the framework, and then you could develop your own rule based on this ratio. And if, for example, you think that if your tests in this PR have less strength ratio rather than, for example, 70, then fail. Then of course you would need to fix it, because you would not be able to merge your PR. But I don't know. Probably, I hope I answered your question, but like short answer, it depends, and this is truly how you guys do it in your team.
Cool, thanks. Let's answer one more question and move on. So we have Vlad asking, sorry, I lost the question. We have Vlad asking, have you had any experience using the screenshot compare feature, and how reliable are these checks?
Sorry, no. Actually, I never used screenshot any tools, any tasks which relied on screenshots. Actually, I never even had this necessity in all the project I worked for, but without practical experience, I would say that I cannot see any really good points of the benefits that these frameworks could give rather than not. I think that this would contribute more to flackiness, and that you will need to waste your time to always double check if it's good or not. And probably I would not also rely 100% on such frameworks, because it's just like comparison. But still, probably there are benefits, and probably the project which in which screenshot like this comparison by screenshot is used can be useful, but I never tried, and for now I don't see any possibilities where I would like to introduce this.